We're going to talk a little more about exponents. So remember from our previous discussion that this column represents what's happening in the base of your exponential, what's on the bottom, and this column represents what's happening in the exponents of your exponential, the little number in the top. And these things are related in that what's happening in the base is always one step higher in this hierarchy than what's happening in the exponent. So for example, if you have exponents being raised to exponents, that means you're going to multiply those exponents. If you have things with the same base that are being multiplied or divided, that means you're going to add or subtract the exponents. And if you have things with the same base that are being added or subtracted, that means you do nothing with the exponents. So for now, we're going to focus on this middle relationship. When you multiply or divide things with the same base, that means you add or subtract the exponents. So let's do a few examples. Okay, so let's start out with x squared times x cubed. So here we're multiplying, so you know here in all these examples we're multiplying, dividing, and the bases are x and x, x and y, x and x, and so on. So let's look at the first example. X squared times x cubed. We're multiplying things that have the same base, which means that we should add the exponents. So x squared times x cubed will be x to the 2 plus 3. See, because the exponents here were 2 and 3, so now we're going to add them up, giving us a grand total of x to the 5th. Not an s, that's a 5. Okay, so now let's look at this. X to the 4th times y to the 2nd. Now here your bases don't match. Okay, so is that a problem? Yes, it is. You have to have the bases the same if you want to combine these things. So this doesn't simplify. Okay, you just take your x to the 4th and you leave it alone, and you take your y to the 2nd and you leave it alone, and that's as simple as it gets. If things don't have the same base, then they can't combine together. Okay, so now let's look at a division example. Here we have x to the 8th divided by x cubed. So in the same way that in the first example, multiplication corresponds to addition of the exponents, division corresponds to subtraction of the exponents. So this is going to be x to the 8 minus 3, or again, x to the 5th. That one looks a little better. Okay, so these are some sort of standard issues. So now let's deal with things that are just slightly more complicated. Okay, so here we have x cubed times x to the 1/2. So all of that 1/2 is in the exponent of this second expression. Now again, the rules are the same, but students don't like fractions for some reason. But here you have two things with the same base, both have base x, and you're multiplying those things, which means that you should add the fractions. Okay, so this will be x to the 3 plus 1/2. And you'll likely want to combine those to be a common fraction. We won't talk about how you do that in this video, but I'm sure you can find some others online that will tell you how to do it. So this is 6/2 plus 1/2, or x to the 7/2, and that will be your answer in this case. Again, the rules don't change. Don't let fractions fool you, okay? This isn't harder because there are fractions. It's the same rules as always. If you're multiplying things with the same base, that means that you add the exponents. Okay, now let's look at some that don't have just a 1 as a coefficient. So all the ones we've dealt with so far was just a single x to the cubed or a single x to the 1/2. And now here we have 2x cubed times 3x to the 5th. What you want to do here is consider the numbers in front of the x's and multiply those together, and then act like you just have x cubed and x to the 5th by themselves. So we're going to reorder this and think about this as 2 times 3, and then we're going to multiply that with x cubed times x to the 5th. Well, 2 times 3 is, of course, 6. And x cubed times x to the 5th. Since we're multiplying things with the same base, the base in each of these is x, that means that we add the exponents. So this will be x to the 3 plus 5, or 6 times x to the 8th as your final answer. Okay, now let's look at one that uses both multiplication and division. Okay, so order of operations says you want to simplify the things in the parentheses first. So first we're going to think about what is x to the 5 divided by x to the 3. And when you divide things that have the same base, that means you subtract the exponents. So here, simplifying what's in the parentheses, this will give us x to the 5 minus 3, because that's the simplified version of what's in those parentheses, and then we're going to multiply whatever that is times x to the 6th. Okay, so this will be x, 5 minus 3 is 2, so this is x squared times x to the 6th. And now we're multiplying things with the same base, so we know exactly what to do. We add the exponents. So this will be x to the 2 plus 6, or x to the 8th. So this is the rule for when you're multiplying or dividing things that have the same base. Remember, it's always one step down in order of operations. So if we were multiplying or dividing, we move one step down to addition of subtraction. Okay, so remember, looking at our hierarchy at the top, these represent the order of operations: exponents, multiplication and division, addition and subtraction, and then nothing. You always want to go one below what's happening in the base. So if you're multiplying and dividing in the base like we were here, what that means is you're adding or subtracting the exponents.